Okay, so welcome back to the RhinoCAM setup tutorial in the CNC workshop. This one we're going to cover the process for horizontal contour. I'm going to give you a process generating a toolpath that makes kind of horizontal contour geometry. So you first go ahead and open up the machining operation. We go down to 3 axis, and so these are all the toolpaths we have. I'm actually going to go straight down here to where it's horizontal finish. And then this is going to be all the settings for setting that. So probably not have a region load automatically like that. The first, which is called the control geometry, we want to draw an outline to tell RhinoCAM where we want it to cut and where we don't want it. What I'm going to do is draw a rectangle. I'll use the control tool. Make a closed outline around the inside of our. And down here in control geometry, I'll hit select curve edge region. Then I'll select that. And so you'll see it show up in the viewport highlighted in orange. And once again, that's going to tell RhinoCAM we want it to cut inside that box. We don't need it to cut part of the geometry. The next thing over is going to be to select a tool. Now, in the tools menu, we've had these loaded. First video. If you don't see any tools here, go ahead and go back to the first video and make sure your tool library loaded. But these are all the tools that are kind of available for us to work with on different route bits we have. There's a couple of bits of information to look for when you select a tool. First one, title here is just the number, so that's identified a bit different on the tool when we're cutting. Next bit of information is it's going to say flat mill, or it's going to say ball nose or ball mill. And basically the difference between those, if you look at this little kind of diagram here, flat mill just has a flat bottom. Obviously that's better for kind of orthogonal geometry. The ball mill, a spherical bottom, which is curvier geometry. That. Okay. The next bit of information over is the diameter of the bit. We have everything from a 3/4 inch bit down to a 1/4 inch bit, even an 1/8 inch. And so generally speaking, the larger bits, the ones we'll use for roughing. What roughing is just removing material. So if you're working in something harder than foam, which is what we're working with now, you'd want to do a roughing pass to kind of remove the material relatively quick with a bigger bit, and then go in with a smaller bit and get more detail and going closer. So for us, we're actually going to choose something kind of in the middle, because we're using foam. We don't need to really do a roughing pass first. And we're actually going to choose one of these 2 ball mills here, and we're going to choose number 16. But what the last bit of information you want to look for is going to be the length of the tool. You can find that just by double clicking on any of the tools. And down here where it says tool length, so we have selected. That number 3, that means our tool is 3 inches. And that's something to watch out for, especially if you're cutting like a 4-inch piece of material. You're going to want a bit that's long enough to kind of reach the lowest parts of your cuts without the machine itself kind of running into material. We're going to choose number 16 here. That's our ball mill. In the next tab over, we find feeds and speeds. So feeds and speeds basically means that's how fast the router moves, how fast the bit spins, and everything. We just want to click down here at the bottom, load from tool. May or may not see the numbers change. The numbers didn't change because I already had it selected earlier. But you just want to load the kind of settings for the bit that you've. Every time you choose a different bit, you want to come back here. The next tab over is called clearance plane. We're going to go ahead and leave that default. And But basically what this means is, screen kind of cuts. The router bit is going to move up and go over to where its next cut is and start cutting again. And we want to make sure that it doesn't accidentally run into parts that haven't been cut yet when it's doing that kind of transfer from one toolpath to the next. So generally you want it to be above the kind of stock toolpath to the other, so we can just leave it on automatic for now. Next tab up at the top left here is going to be cut parameters. Under global parameters, we actually have an item called stock. If you look over here on the left hand side, stock means the distance away from the finished surface that the toolpath is. Now again, if you were doing like a roughing pass first, we'd want to set this number to like a 16th or an 1/8 of an inch. You're not cutting to the final surface, leaving that for. Again, because we're just doing one toolpath here, we're going to go ahead and set that as. So on the next tab over, cut level. Now, this step down control item is going to be important. Kind of see why over here. Basically, that controls like how far apart each horizontal toolpath is vertical. We're going to go ahead and set it to distance rather than tool diameter. We're just going to leave it on an 8. So our kind of contours will be in. And then down below where it says cut levels, we're also going to go ahead and set this option bottom. Basically, that just defines the lower limit of like how far the toolpath will go. It's a good idea to always set a kind of bottom limit because even though you might have been careful and your geometry looks fine, oftentimes you can find that like your geometry will have holes in it that you can't really see. And when RhinoCAM goes through and generates a toolpath, it might find one of those holes and cut through your geometry. Number one, that can ruin your part, but number two, it can also then cut into the router bed. We really want to avoid, right? That'll break the machine. So in this case, because we know, that we have that 1/2 inch below our geometry, we're just going to number to 0.5. But you can also select the little cursor icon and then click. In this case, the next 3 tabs over are, we're just going to leave this stuff as for the more advanced settings we don't really mess with here. And then once we have all those settings established, we're going to go ahead and click. And then down at the bottom, so these are where our visibility toggles are again. The first one is our stock. Again, that's just the kind of what we set our box or material to that we're cutting from. And then we're also going to turn on toolpath here. If I select horizontal finishing, we can see in the viewport the kind of path that the machine is cutting. And then what we also want to do every time we generate a toolpath is simulate it. So again, I'll select that toolpath, right-click on the little icon, go to simulate. What that does is, number one, it helps us let us see what the geometry is going to look like when it's cut. But it's also going to help us see, or it'll find, rather, for example, if we had a really short bit here and the machine was going to run into the stock, it would show up in red. So if you go to the software handbook, which is the Caplo website again, just search software guidebook, click on that link, and in the CNC router tutorial section where it talks about how to set up a toolpath, like here, for example, if we chose a bit that was too short, and the machine was going to run into our block, we'd be able to detect it by doing that simulation. So we have that set up. You can see we got one little last thing to look for. You may find that you have these kind of areas that didn't really get cut. That's because horizontal finishing is just kind of looking for basically contours on the final surface to cut. So we're going to go ahead and add one more toolpath just to clean up anything that might have been not cut. Finishing pass. So in my machining browser over here, I'm going to go back to the program tab. I'm going to click on machining operations, 3-axis. I'm going to go down to where it says flats machining, option right in the center there. So what that will do is it'll just find any surface that's kind of flat. And so again, you should only have kind of leftover material in areas that are high points or low points, didn't quite get contoured. And so generally speaking, those are kind of so once again, we have the control geometry. Again, we would just use our rectangle because I did it on the last toolpath that's already selected. Next one over, we're going to keep it at number 16, so we don't have to change the bit. Tab over is feed speed, so I'll just click tool to make it right. Clearance plane again, we'll leave that alone. And finally, we're going to cut parameters. Here's where we kind of get to define down here where it says machining area is flatter than a certain angle. So there's a certain kind of threshold we can set to tell it, okay, we want you to go ahead and recut this area. We'll set this to something like 10 to make sure it gets all of those areas that didn't end up getting cut in the first pass. And the other thing I'm going to look for here, down below where it says step over control, and this defines is like how far apart each toolpath is. Then we always kind of want this number to be 50% or less, because as the router bit is spinning, it's only really cutting with one side. So we want to make sure that that side, so if we set it to 50% or less, it's always cutting with this. So we're going to go ahead and set it all the way to 50% because we're going to work quickly. And then leave enter and exit. So click generate. And if we turn on the toolpath, you can see finding those little areas flat that maybe didn't get cut on the first round, going in and add. So now if we go ahead and see that, it should come in and kind of remove anything originally. Now if this doesn't work, it'll depend on your geometry and kind of what the settings are. If it doesn't work, the first thing to try would be to go back into that. So you can just double click on this, get those settings open again. First thing would be to go to cut parameters and set that angle to a higher number, so it's cutting more of what may not have been cut the first time. And then the other thing to try, if that still doesn't work, would just be to make sure you're getting all of it by turning this. But I want to also point out that on the assignment sheet, we're gonna go ahead and look for, or we're gonna want to use a toolpath that is cutting within a certain time. Some of these toolpaths could be slower depending on your geometry. We don't want to have files that are taking too long because we've got a lot of files to cut. So in order to check the timing on this, we're going to go up to where it says setup, select setup, right click, and we're going to go to this little option, information. That should give us a rough estimate here of how long it's going to cut. We're actually over 5 minutes on this geometry. There's a couple things we could do to fix that. Like go back to horizontal machining, go to cut levels and make this number a little bit bigger. We do like 3/16, 0.1875. And once again, we would want to simulate that again, right? Because now you can see there's actually areas, because we're cutting less with the horizontal finishing, actually more areas that plateau machining will need to clean up. Go back in here as well and then degrees. And yeah, we just go ahead and keep kind of turning that. Getting clear that you need there. Then we can go ahead and check our timing again. But I do want to emphasize that like something isn't really kind of seeming like it. So there we go. So that would. But if something isn't seeming like it's gonna cut in short enough a time period, so again, our timing actually got better by doing that. So we would want to really actually choose a different toolpath then to try and try and get our number down, I would recommend going to parallel finish that. But depending on your geometry, this could. Once you're all set up, assuming your time estimate is below the 5-minute limit there, what we want to do next is actually post the file. So again, in your assignment sheet, it's going to say step 5 is to post and check. In order to post it, we should have our post processor set up from the first tutorial, setup tutorial. We're going to select setup again, make sure that it's highlighted there. Right click and select post. So under save as type, we should see it .cap. Under current post, we should see Chop Saber, CNC, UA. If you don't see those two, again, go back to the first RhinoCAM setup video. I'm going to go ahead and rename that. And so this is actually the, like the G code file. Cool. It's not loading our post processor. So again, in order to load that post processor, you'd want to go to the software guidebook and go up to third page. Here, and it's going to tell you that that's the directory you need to go to find the post processor, and go and open our file browser, type in that directory. It's // student forget what the Materials Laboratory. MATLAB. So we'll just go /. And it looks like I may not be a problem here. Oh, I typed it in wrong. I'm sorry. So it should be this // apla-student.catnet.arizona.edu /MATLAB, and then go to the RhinoCAM folder here, go to post processor. We're going to want to load that in. I can copy this directory over. Paste it in the line there. And post it one more. Alright, well, not sure why, but for some reason it's not working for me. But in any case, it should work for you. And when you go ahead and do that, what you'll find is that kind of notepad file will automatically open. Again, you can follow along in the PDF tutorial to this part. Here on my 16. And what we want to do is actually search the file for any lines of code that are problematic. This is actually the G code file. You can see, basically it's a series of X, Y, and Z values, and those kind of represent location. So the router basically just follows these kind of locations and moves from one point to the next, kind of traces out the toolpath established in Rhino. And what that means is because we've zeroed to the bottom of the bed, we've zeroed to the bottom of our part bed of the router. If we find any Z values that are below 0 or negative, that means that the router is actually going to cut into the router, try to cut into the router. So what we want to do is just search this file for negative Z values. If you go to edit, find, where you can hit Control F and search for Z minus. Hit find next. You should see that cannot find Z minus. If you find negative Z value, what you want to do is go back and check your file. Again, you could set up a bottom limit for your two toolpaths, or you could look for, maybe there's a hole in your so you don't have any negative Z values, which you shouldn't. The next thing you want to search for is M5. Basically, that's going to happen. It's going to pop up anytime you have a tool change, and basically at the end of the file. Little code that means the router's going to stop cutting at that point. You just want to verify that, like, your tool changes are correct, and that the file is correct. Once you've done that, go ahead and close. So if those two steps are kind of clear, then you want to just go ahead and save your Rhino. So make sure that you, when you upload that file to D2L, you want to upload the Rhino file, because otherwise we won't be able to check it and kind of verify that the setup is correct, and we won't be able to run it. Check it. So what you want to do is just go File, Save As, rename it with the proper convention, 242 2020S, CNC Workshop, and make sure you put your name in it. That's very important, so we can kind of identify, and then go ahead and save that file. And that'll be the file that you upload to D2L, and it should bring your kind of RhinoCAM. Okay. That should be about it for this tutorial. And so if you've gotten this far, I think you're done. You'll be able to come back the next day or have your TA check your Rhino file. You'll be able to go ahead and cut.